welcome to my series of videos of using the LogixPro 500 simulator for programming PLCs. In this video, we are going to look at programming the garage door. The garage door exercise can be found under the Help menu. So you click on Help, go to Student Exercises, and this should open up in your browser, even though it is a web page that is found locally on your computer. No internet required for this. And you want to click on Door Simulation, and that should take you to this screen. Again, this is in your web browser. And then you can scroll down and you'll get a little background information about this particular simulation and what's involved. And then we're going to go into exercise number 1. And that's what we're going to walk through now. So let's look at the simulation. So I'm going to minimize this screen from the browser, and we want to go into LogixPro. This is kind of how LogixPro will start up. In the center of the screen, you can move the simulation window and your ladder programming window. You can resize both of those by just simply dragging as such. And so I usually like to fit the simulation in the left pane, and then I have the rest over on the right side saved for the programming. And your computer may behave just a little differently, so you'd adjust it to fit your particular preferences. Okay, so up at the top, let's click on Simulations and go to Door Simulator. This is the garage door, and so that will open up as such. And I'm going to adjust the window. That looks pretty good, about midway for me. But again, it depends on your monitor or your computer or laptop, and your screen resolution and all that will have an effect on this setting. So just make sure that you can see all the components that have to do with the garage door, and then make sure you have plenty of room over on the right-hand pane for writing our program, and you can always adjust as we go. All right, so let's look at what we got. Let's find out the components that we have available with this particular process. We have a garage door, so this is a large industrial type door, and it looks like it has 2 motors, a motor up and a motor down. So each one of those would be separate outputs for the PLC. Obviously, if we energize motor up, that's probably going to make the door go up, and if we energize motor down, that would make the door go down. We also, over on the left-hand side of the door, we have 2 limit switches. We have an upper limit switch that probably lets us know that the door is fully open. And then we have a lower limit switch that probably lets us know that the door is fully closed. And so we need to know a little bit about these limit switches, but we'll get to that point in time. Over on the left-hand side is our control panel. And it looks like we have 3 indicator lights, an ajar light, an open light, and a shut light. And these are technically pilot lamps, and they're probably interfaced directly to the output module of the PLC. And then we have, looks like 3 push buttons. We have an open push button, a close push button, and a stop push button. Okay, so now we have an idea of what we're working with and what it's going to take to get this door to operate. And so we're going to take this program in baby steps. That way, if you have an issue, you can always rewind and come back to an earlier part of the video and review it to make sure that you understand as we move along. So the first thing that we need to do is, obviously the door is closed. So we want to work with probably making the door go up as our very first thought process. So the way that I like to teach PLC programming, it's a good method for learning PLC programming, is to make sure that each of your outputs that you're going to control, whatever outputs are in your process that you need to control, they each have their own rung. So we're going to start with motor up, and so I'm going to come up and grab the output energize instruction, and I'm going to drag it to a red box. It'll turn green. You can let go. And you can see now I have an output energize instruction placed on a rung. Notice it created the rung automatically, or I could have clicked the create or new rung tool, and it would have created a new rung, but it did it automatically. It knew that I was about to place an output, and it can't put it on the end rung, so it did a new one for us. So I have an output. That output is going to be motor up. And there's two ways to handle the address here at the question mark. The question mark is letting me know that it needs an address. All instructions need an address. And so I can actually drag this address over. I can click and drag, and I can drag it to the question mark. And then when I get it in place, you'll see a plus box pop up, lets us know that we can drop that address in place. The other option is you can double click on the question mark and you can type in O:2/0 and hit enter. Either way, I like the drag and drop method because you always run into a chance of a typographical error or typing something incorrectly into an address, and then your program will not work and you'll have to spend time figuring it out. So if you just drag as many addresses as possible, you reduce the chances of having a mistake on your addressing. All right, before we go any further, I'm going to right click on this instruction and I'm going to hit edit symbol. And we're going to give this instruction a name, and I'm going to call it motor up. So just giving it a label, that's all. It's just so I know what each instruction is that I put into my program. All right, so this rung, if we don't do anything but at this point, if we were to download this program and test, motor up would stay on all the time. And that's all that would be controlled so far in our program. But we don't want motor up on all the time. So I guess it's a good time to go back to our expectations for exercise 1. Let's go back to our expectations and read what they tell us. In this exercise, we want you to apply your knowledge of relay logic instructions to design a program which will control the LogixPro door simulation. The door system includes a reversible motor, which is basically a motor up and a motor down that's independently controlled. A pair of limit switches. Remember, we had one for the upper limit switch and one for the lower limit switch for open and close, and an operator control panel, all connected to your PLC. The program you create will monitor and control this equipment while adhering to the following criteria. In this exercise, the open and close push buttons will be used to control the movement of the door. Movement will not be maintained when either switch is released. So in other words, when you let go of the open or the close push buttons, the motors will stop. So therefore, the stop switch is neither required nor used in this exercise. So that's a good thing. We don't have to worry about the stop button right now. However, all other available inputs and outputs are employed in this exercise. Okay, makes sense. Pressing the open switch will cause the door to move upwards or to open if the door is not already fully open. The opening operation will continue as long as the open switch is held down. If the switch is released, or if limit switch LS1 opens, the door movement will halt immediately. Okay. All right, makes sense. Pressing the close switch will cause the door to move down or close if not already fully closed. The closing operation will continue as long as the switch is held down. If the switch is released, or if limit switch LS2 closes, the door movement will halt immediately. So very similar to the open. So the open and the close process are very similar to each other. One's obviously opening the door, moving the door up, and the other one is moving the door downward. If the door is already fully opened, pressing the open switch will not energize the motor. In other words, you can't go any more open than fully open. And if we tried to do that, then we could possibly burn up the motor. If the door is fully open and you energize the motor, that would damage the motor. Likewise, if the door is fully closed, we don't want the closed or the closed motor or motor down to be energized. Under no circumstance will both motor windings be energized at the same time. So in other words, you don't want somebody to come over and be able to press open and close at the same time, because somebody will do that sooner or later. And so we don't want the door trying to go up and down at the same time. The open lamp will be illuminated if the door is in the fully open position. The shut lamp will be illuminated if the door is in the fully closed position. It is your responsibility to fully design, document, debug, and test your program. Avoid the use of OTL and OTU latching instructions, and make a concerted effort to minimize the number of rungs employed. Okay, all right, I think we've got enough to work with. Let's continue on. So back into LogixPro, we have started our program with motor up on our first rung. And now I need to think about, when does motor up need to be energized? Okay, well, motor up needs to be energized whenever I press the open push button. The open push button is a normally open push button, so normally the switch is open, and if I press it, the switch will close. So I need an instruction on the rung here that will be true whenever the switch is closed. So I need an examine if closed instruction. So I want to drag this over like so. And this is going to be my open push button. So I'm going to drag the address for the open push button over to the question mark. And then I'm going to right click on the instruction and then hit edit symbol. And I'm going to call this open PB for open push button. So now this rung says whenever open push button is closed, this instruction will be true. And when that instruction is true, motor up, the output energize instruction will be true. And so motor up will be energized. So if I press the push button and I hold it, then motor up will be energized. Okay, so that gives me something that we can test. Let's try it. So let's click the little curly arrow here, and it will take us to our PLC control panel. And now we need to click on download. That will download our program to the PLC. And then click on run to take us into the run mode. And let's press the open push button. And then let go. And you can see it stops. Press it again, open, and then let go. There's a slider up here. This is controls the scan speed and the simulation speed. So we can increase that a little bit and the door will operate faster, like so. Let's go on just a little faster. Whoops, not all the way. Let go of the open push button and it stops. Like so. I'm going to turn the sound off. Hope you don't mind. Let's turn the sound off. All right. And press the open button. Uh-oh. Fire detector. Motor stalled. This has resulted in a motor burnout, which in turn caused a fire. So let's hit clean up. Okay, what happened was whenever the door got to the fully open position, the open push button, if I still held the push button down, it would still cause motor up to energize. So I need some way that the motor, even if I'm continuing to hold the open push button, the motor will stop automatically when the door gets to the fully open position. So let's go back to the program mode and go back to our palette of instructions. And we're going to have to use the limit switch because I have to think, what do I have available to me that's going to let me know that the door is fully open? Well, I have a limit switch, this LS1. And LS1 is a normally open limit switch. They tell us that it is not activated or the limit switch is open when the door is fully open. Otherwise, this particular limit switch is true or closed. So in other words, we got a limit switch up here that when the door gets fully open, the door does not touch the limit switch. And so the switch is open. As soon as the door begins to come down out of the fully open position, it hits this switch and closes it. And then for the rest of the travel of the edge of the door is touching the side of that limit switch and keeps it closed. So I need to use this limit switch to be able to open the motor up whenever the door is fully open. Well, when the door is fully open, the limit switch is open. And I need the motor to de-energize or to go false. So I need an examine if closed instruction here. And I'm going to drag over the address for the limit switch. And I'm going to right click and I'm going to label. And I'm going to call this LS1. That's the top limit switch. You could actually name it open limit switch. That would be good too. You can label it anything you would like. But going along with the naming conventions that are used here in the process, I'm going to stick with those and call that LS1. All right, so let's revisit. Let's go and download the program. Anytime you make an edit, you have to download the program. Go back to the run mode. And the door is fully closed. And you can see that the LS1 instruction is true. It's true because currently the limit switch is closed because the door is up next to it because the door is fully closed. And that's good. If you happen to have picked the wrong instruction, then this instruction would be false right now, and closing the open push button by pressing the push button would not energize the motor. And then you would realize that you had a mistake. But it looks like we're doing good so far. We've picked the correct instruction, and let's press open. Oh yeah, let go of open and it stops. Press it again. It opens. Now I'm holding down the open push button, and you can see over in the program, now when I press open PB or the open push button, it will not energize motor up because the LS1 instruction is keeping the rung false because the door is fully open. So good job. Hopefully you did that along with me, and so far so good. So it looks like our motor up is working properly. So notice that the door fully opened, and once the door got fully open, then it automatically stopped and we can't open it any further. All right, so back to the instruction palette. And now the door is fully open. The next thing we need to do is get the door to fully close. So to do that, we have to use or activate motor down. So we need another rung. So we're going to get an output energize, and it's going to start a new rung for us. Remember that each output that we're trying to control is going to get its own rung. So we're going to have a rung for motor up. We're going to have a rung for motor down. And eventually we're going to have a rung for whatever lamps or pilot lamps that we are trying to illuminate. So our second rung is going to be motor down. So let's go ahead and get the instruction, or excuse me, the address for that. That is output:2/1 or O:2/1. I'm going to right click on the instruction, and we're going to call this motor down, or motor DN for down, or you can type it out. That's up to you. Now, when does motor down need to be activated or true? Well, it needs to be true whenever we press the close push button. The close push button is also normally open, just like the open push button was. So we're going to do a very similar thing on our motor down rung. So let's get an examine if closed and bring it down. And that is going to be our close push button because that's what is controlling the motor down. And then let's right click and go ahead and label it while we're here. Close PB. And we're going to have a similar situation. I'm not going to test this because we know what's going to happen. If I hold the close push button down, and then when the door gets fully closed, the motor down will stay energized and it'll burn the motor up. So we need to have, we got a limit switch here. So let's use this limit switch to automatically stop motor down when the door gets fully closed. So LS2 is a normally open switch, and whenever the door gets fully closed, the end of the door will touch the limit switch and close it, and that's supposed to let us know that the door is fully closed. So when the limit switch is closed, we need an instruction here to be false or to open to cause motor down to de-energize. So we need an examine if open. When the switch closes, we want the instruction to be false. So it's like an opposite relationship. It's going to be different than what we did for LS1. So let's grab the instruction or the address, excuse me, the address for LS2, and let's change that to LS2 like so. Now let's download our program and let's test it. Download, hit run. Okay, currently the door is fully open. So obviously if I press open, nothing should happen. And if I press close, the door should begin to close. And if I let go of the close push button, it should stop. That's normal. And now the door is fully closed, and pressing the close push button will not energize motor down. I can go back open, and I can go close. Awesome. All right. So we currently have the door operating. Yay. So open push button is controlling the motor up, and LS1 is causing the motor up to automatically stop if we don't stop it in time by letting go of the open push button. And then the close push button is operating motor down. All right, so far so good. What's next? The next would be our lamps, and they only told us 2 lamps for this exercise, for exercise 1, and that would be the open and shut lamp. So let's go ahead, let's go back to program mode, go back to our palette, and let's bring in an output energize. Let's go ahead and do 2 of them. Let's go ahead and create 2 new rungs. And the first rung is going to be the open lamp. So I'm going to drag over the address. I want to right click and call this open PL for open pilot lamp. And then I'm going to drag over the other address and right click, and this is going to be shut PL for shut pilot lamp. So I have 2 rungs created for those 2 outputs. Remember, each output gets its own rung, and everything that has to do with that output will be done on that specific rung. Okay, so when does the open pilot lamp need to be illuminated? Well, it needs to be illuminated whenever the door is fully open. It has to be in the fully open position. So how do I know when the door is in the fully open position? I have a limit switch that tells me. This limit switch here is open when the door is fully open. So when that limit switch opens, I want it to energize the open pilot lamp. So I have to use an examine if open. Bring over an examine if open. And it's going to have the address of the limit switch. And boom, see, the label is already there because we've already used that particular limit switch in our program. And we can use inputs as many times as we would like in our program. No problem in doing that. So that should take care of the open pilot lamp. When should the shut pilot lamp be energized? Well, when the door is fully shut. So do we have something that tells us that the door is fully shut? We do. And that would be LS2. So let's bring in, first of all, we need to find out what's going on with LS2. Well, when the door is fully shut, this limit switch closes. And it's open the rest of the time. So we need an examine if closed, which says that this instruction will be true when that input is closed. And that input is closed when the door is touching it. That means when the door is fully shut. So let's drag over the address. And we have LS2 is already labeled. So once you label a particular input or an output, you don't have to label it a second time if you use it a second or third or fourth time. Okay, looking good so far. Let's test it. So let's go back. We got a download. And then let's go to run mode. Oh, well, looks like we have a shut lamp that is on. And that's good because the door is shut. So let's press open. Okay, notice the shut lamp went out. It's cut off because the door is no longer fully shut. And let's go all the way open. And now the open light comes on. It lets me know that the door is fully open. And I can't open the door any further, which is great. Go to close. It should stop when I let go of the push button. And then go to fully closed, and the shut light comes back on. All right, one last thing for this program. They told us that under no circumstance can we energize both motor up and motor down at the same time. And it's possible that we could do that. In a situation where the door is not fully open or fully closed, somebody could at this point walk over and actually, I can't do it in the simulation screen because I've only got one mouse pointer, but someone could come over and press open and close at the same time. And what that would do is I can come over here and look at my program, and I could tell that if I close the open and the close push button at the same time, motor up and motor down will both energize, and that would be bad. We don't want that to happen. So we can put in a little programming trick to prevent that from happening, and that's called a safety interlock. And to program that, all we have to do is take an examine if open and put right here for motor up. And what we're going to do is we're going to put the motor down here. We're going to grab the motor down address and put it there, just like that. What that is going to do is it tells us that anytime motor down is energized, this instruction will be false. And if that instruction is false, then you cannot energize the rung with motor up on it. We're also going to do this very same thing on motor down, except we're going to use the motor up address. Same thing here. If motor up is energized, this instruction will be false, and we will not be able to energize motor down. So this assures that only one motor can be energized at the time. So let's download and test just to make sure it does work and we haven't done anything that has upset what we already had working, which sometimes happens. Okay, going up, no problem. Fully open, and our open light's on. And then close. Fully closed, and our shut light is on. All right, I'm going to go back to our browser that was open, and let's make sure that we got everything right. The open and close push buttons, we got those right. The open switch will cause the door to move up if it's not already open. If the door is already fully open, pressing the open switch will not energize the motor. We got that correct. Same with closed. Under no circumstance will both motor windings be energized at the same time. We did that. The open lamp will be illuminated if the door is in the fully open position, and the shut lamp will be illuminated if the door is in the fully closed position. So I'm going to minimize that again. So it looks like we got a working program. So this is the answer to the door simulation exercise 1. So let's go to the program mode and let's save this. Let me show you how to do that. Go up here to the top left, hit File, and then Save. And it will open up this Save dialog. And normally I like to just save it to the desktop. I can always move it later. Just click on Desktop over on the left-hand side. And let's create a new folder. And we're going to call this LogixPro. Let's do LogixPro Labs. I like that. And then double click on that. So now we have an empty folder that's going to hold all of my LogixPro Labs on the desktop. And we're going to call this Garage Door EX1 for exercise 1. And then I'm going to click Save, and it should be there. And we can go and look at that. And let's do that. Let's bring up my File Explorer. I have a shortcut to that. And let's go to the desktop. And then I should have a folder called LogixPro Labs, which is right there. And there it is, Garage Door Exercise 1. Not a big file at all. It's only 2 kilobytes in size. And I'm going to minimize that. So there you go. That is the garage door exercise 1 explained. And I appreciate you tuning in. Be sure to check out the next video where we're going to look at garage door exercise 2. Thanks, guys.